Hello guys, welcome back to my channel. Mason African Motives, still working on mathematics N3. So this is the question paper which was actually written on the 4th of February 2022. So we shall be working on this question paper and see how we're supposed to calculate the given questions, if there are any errors that we have made, so that you see and actually mark yourself on what you have produced from the questions that we are given, so that you can also prepare yourself to know what is to come next and prepare, so that you know, are you going to focus on this level again, or you're going to focus on another level. That is the importance of revising this in time. Okay, so the first question that we had was to factorize the following as far as possible in prime factors. So we asked to factorize this in prime factors. Okay, the given expression that we have to factorize this in prime factors. Okay, and we are given an expression which was a squared minus 4x squared plus 4x minus 1. This was the expression that we are given in order for us to factorize. I want you to take note from this question that if you are to cross-check on this part that we have a quadratic expression in terms of x. So if we can separate that part, focusing much on a difference of two squares, we'll see that we are going to have something like a squared minus, that is, if we are to factor out a minus, in this case, if we are to factor out a minus, this part is going to be divided by minus, so that is going to be minus 4 divided by minus, which is going to give us 4x squared. We have 4x, this is a plus, and a minus, which is going to give us minus 4x. Minus 1 and minus, if we divide, is going to give us plus 1. So we are having a quadratic expression of 4x squared minus 4x plus 1. Okay, let's focus on this quadratic expression that we have in this case. What actually can we have from this quadratic expression? If we are to factorize this quadratic expression, what do we have? As we can see in this part, the coefficient of x squared is 4. It is not 1, so you have to multiply the first term and the last term. So if you multiply these, you're going to obtain 4x squared. So using the factors of 4x squared, which two terms that we can multiply, that gives us 4x squared. But if we are to add these factors, they are supposed to give us the middle term, which is minus 4x. So take note of these factors that you are going to work with. Since there is a negative, we are going to focus with numbers having a negative. So you can choose minus 2x and minus 2x. If we multiply these, they are going to give us 4x squared. If we add these two terms, they will give us minus 4x. So these are the terms that you are now going to replace into the middle term, so that we have something like 4x squared minus 2x. We replace these middle terms, minus 2x plus 1. Okay, so for the first two terms, because we now have four terms like this, so you have to group them into two. So for the first two terms, what is common there? We have to ask ourselves what is common between 4x squared and 2x. What is the highest common factor? So between 4 and 2, we have 2x. So if we divide 4x squared divided by 2x, definitely you're going to obtain 2x, because we have 4 divided by 2, which is 2, x squared divided by x, which is x, minus 2x and 2x, which gives us a 1. Okay, then factor out negative, so that this becomes a positive. So factor out negative 1, this is going to give us positive 2x, minus 1 is plus 1, divided by minus 1, which is negative 1. These two brackets are the same, so actually you can factor out this bracket, which is 2x minus 1. What is remaining? We have 2x and minus 1. We are remaining with 2x minus 1. Okay, these are the two brackets that we are remaining with. But from our numbers, we know, guys, that a by a is same as a squared, a to the exponent of 2. So if these two brackets are actually multiplying each other just like a and a, we can just write it as 2x minus 1 like this, to the exponent of 2. So this is the final answer for 4x squared minus 4x plus 1 in terms of the factors that we have in, which is giving us two brackets. So we can replace this this part in place of this 4x squared minus 4x plus 1, because we have factorized this part. And what did we obtain? We obtained this bracket of 2x minus 1 squared. This is what we obtained. Okay, we actually know that this is now difference of two squares, because we have a square and we also have a square. So from difference of two squares, we know that if we have a square, we're going to have two brackets like this. And writing these numbers under this square, which is a, so we have a, one bracket is going to add plus this part which is under the square. We are having a square here, so this is the one that is representing like b. If we have b squared, is supposed to be a plus b, so our b is representing 2x plus 2x minus 1 like this. Okay, we move on to another part which is going to subtract. So as we can see, our a is going to repeat, but this time we are subtracting 2x minus 1. So for negative, we are going to write it in bracket, because remember, a negative, when it multiplies, a negative is going to change the sign, but a positive does not have any effect. That is why I didn't even bother to put that bracket, but we are supposed to write it. Okay, so we are going to have a plus 2x minus 1, because these cannot be simplified. These are unlike terms at all. Okay, into, we multiply our negative, which is a negative, by positive 2x. As you can see, negative and positive, that's a negative 2x, negative and negative, that's a positive 1. So you see now the effect of a negative, that the negative is going to change the sign that you are given. If it is a minus, it's going to change to a positive, something like that. So these are the prime factors that we are having from the question that we're given. So if you are given a question to factorize in this form, that is what you actually need. Okay, the other question you're given to factorize the following polynomial expression completely with the aid of factor theorem. Okay, this is the expression that we are given. And we are given that we are supposed to be aided or to be helped by a factor theorem, where we are given that f of x is equivalent to minus x cubed plus 6x squared minus 9x plus 4. Okay, we understand, or we know that from a factor theorem, if we say we have a factor, when we substitute that factor, the value of x that we are referring as a factor, we must obtain a 0 into that expression. So it's a trial and error, where you are focusing with the factors of the last term, which is 4. So you can try to work with plus or minus 1, plus or minus 2, plus or minus 4. These are the factors of 4. So you can try which one is going to give us a 0 in this case. Okay, so we have minus x cubed. Let's try minus 1. So that will be something like this, minus 1 cubed. Okay, plus 6x squared plus 6 by minus 1 squared minus 9x minus 9 by minus 1 plus 4. Okay, this one is giving us 18. It's not giving us the value, so which means minus 1 is totally out. We move on to plus 1. So this one is 1 minus 1 cubed. So that one was there was a minus there. I didn't see it. Okay, this one is supposed to be minus 1 cubed like this, which is minus 1 cubed is same as minus 1. Okay, plus 6 into 1, that one is same as 6 minus 9 times 1, which is same as 9 plus 4. Okay, this one is giving us a 0. So when x is 1, we are actually obtaining a 0. So this one is the right part that we need. So on a condition that x is equivalent to 1, we are obtaining a 0. So what does this mean? It actually means that x minus 1 is a factor. Take note, the value of x as a solution is x is equal to 1, but x minus 1 is a factor. That is from our factor theorem. So in this case, what we need is to factorize, so which means we have one factor already, which is x minus 1. So what are we going to do? We are going to apply now the part of long division. So we have to go through the long division in order for us to factorize, because we need at least to have a quadratic part, a quadratic expression. So this quadratic expression can only be achieved by long division. Okay, so we are going to divide by the factor, which is x minus 1. So using the concept of long division, we have something like this. So our factor is x minus 1 into the cubic expression, which is minus x cubed plus 6x squared minus 9x plus 4. This was our cubic expression. So when we divide, remember, we have to apply x. So we divide by x, so it's x into minus x to the exponent of 3, or just this minus x to the exponent of 3 divided by x, which is minus x to the exponent of 2, like this. Then we multiply back by minus x to the exponent of 2, this part of x minus 1. So it's x minus x to the exponent of 2 times x, which is minus x to the exponent of 3, minus x to the exponent of 2 by minus 1, which is plus x to the exponent of 2. We have multiplied everything. After multiplying, we are going to subtract now this expression minus the part that we were multiplying. And what are we going to obtain if we subtract? As you can see, this is minus, minus and minus is a plus. So it's same as minus 1 plus 1. So that one is a 0. We move on to 6x squared. So it's 6 minus plus. Plus and minus gives us a minus. So it's same as 6 minus 1, which is 5. Or you can just use a calculator. That's something like you're saying 6 minus plus 1. Something like this, plus 1, which is going to give us 5. That is what we have, but we have x squared here. So it's going to be 5x squared. Then these numbers, you just drop them as they are because they haven't affected anything. So you have minus 9x plus 4. Okay. We divide again using the same x. So it's now 5x squared divided by x. 5x squared divided by x, which is plus 5x. After dividing, we multiply back. So it's 5x times x, which is 5x squared. 5x squared times minus 1, which is minus 5x. After multiplying, as usual, you have to subtract. Okay, so if we subtract, it's 5 minus 5, that's a 0, this one. Then we have minus 9 minus minus 5. Let's just do it this way. We have minus 9 minus this one for subtraction sign. Then for minus 5, you use this negative here for minus 5. So it's minus 5 like this, which is minus 4. So we are obtaining minus 4x because there's x here. Then this 4 is not affecting anything, so it's plus 4. We divide again. That's x into minus 4x, which is minus 4. So we're going to have minus 4. Multiply back again, minus 4 and x, which is minus 4x, minus 4 and minus 1, which is a plus 4. Then we subtract as usual. So as you can see, this one is minus and minus, which is a plus, so definitely obtain a 0. You obtain a 0. 4 minus 4, that's a 0, so which means here there is nothing that is going to remain. So obtaining zeros here, it's an indication that truly x minus 1 is a factor. If you do not obtain a zero, maybe you remain with a number like 7, it means that number or that expression that you used to divide is not a factor. But when you obtain 0, 0 like this, it means x minus 1 is a factor. And also this quadratic expression on top, this one, is also a factor. So what are we having at the end? We are having something like x minus 1, which is a factor, and also another factor, which is this quadratic expression of minus x to the exponent of 2 plus 5x minus 4 like this, which is also another factor. So in order for us to factorize, we can actually factor out the negative first from this, since x is affected by negative. So if factor of all negative is going to be negative into x minus 1 like this. Okay, then if you factor out negative, this one, it's minus x squared divided by minus, which is positive x squared, plus and minus, which is minus 5x, minus and minus, which is plus 4. Okay, so now we can actually factorize easier in this way, where we just need to focus on this number 4, since x squared, the coefficient of x squared is 1. So what are the factors of 4 that we can add so that we obtain minus 5? So since these factors of 4 will give us minus 5, we have to consider factors with negative. So consider something like minus 4 and minus 1. If we multiply these two, we obtain positive 4. If we add these two, we obtain negative 5. So we have x minus 4 and x minus 1, something like this. So you can actually multiply by negative back. That is, if you want, or you can just leave it like that. Still, you have factorized, because what is important in this case is to factorize. It's not about actually representing that this effect. No, factorizing is putting in brackets like this. So you can even multiply back even one bracket like this by negative. If you multiply this by negative, you can obtain something like 1 minus x into x minus 4, x minus 1. You just multiply one bracket because it's going to multiply other brackets. So you can write your answer as this or in either way. And also, if you are to consider this part, there is x minus 1, is x minus 1. So also you can write your answer like minus into x minus 1 squared like this into x minus 4. Still one in the same thing. From this stage, you can also write it in this way. So depending with the way that you have written, but as long as you're at this stage, you have the final answer. Okay, then on questions 1.3, we're asked to simplify the following expression. Simplify the following expression, and we had 7 marks for that, to just simplify that expression. That is x plus 1 over, we are given the expression of x plus 1 over x squared minus 3x plus 2 minus 2 over 1 minus x. So I want you to take note of this expression, guys, so that you actually understand what we're given. It's always best that when you are working with expressions, whether you're adding or subtracting, that you factorize the denominator. The denominator that you're given, you must factorize it clearly. So if we are to work on this part, we are given x squared minus 3x for the first fraction plus 2. If we are to factorize, since in this case the coefficient of x squared is 1, we just have to write 2 brackets where we have x and x. We work with the last term, which is the constant 2. So it's positive 2. So what are the factors of positive 2 that we can actually add to obtain the middle term of x, which is minus 3? So what are these two numbers that we can multiply to obtain positive 2? So we only have two sets in this case, 2 and 1, minus 2 and minus 1. But of these two, which part are we going to add to obtain minus 3? Definitely is this part with negative, because if we add there, we are going to obtain minus 3. So we have x minus 2 and x minus 1. So these are the two brackets that we are obtaining, x minus 2 and x minus 1, from this part. So we can actually write this as x plus 1 over the part that we obtained, which is x minus 2 and x minus 1. X minus 2, x minus 1. Okay. I want you to cross-check something in this case. Yes, we're supposed to write like minus this fraction that we are given as it is. But there's something that is common that we need to simplify. It's very, very important for you to note on this part. If you are to cross-check, we have x minus 1. On this part, we have 1 minus x. So if this is x minus 1, if you can see, we have x minus 2, x minus 1, starting with x here. It is the same as writing like minus x plus 1 like this. But as you can see, it's not x like this, because these ones are carrying a negative, a positive. This one is carrying a negative. But these two, they are having a positive. It's positive x. So how can we write this expression of 1 minus x in terms of positive x? Since this x is carrying a negative, or is having a negative, we are going to factor out the negative that it is carrying or that it is having. So if we factor out negative, which means it's minus x divided by minus, which is positive x, plus 1 divided by minus, which is minus 1. So minus x plus 1, which is same as 1 minus x, is the same as minus into x minus 1. So we are now having a minus, and this bracket is now in the same order as these two brackets, starting with positive x. So now replacing this minus where there is already a minus on our fraction, what is going to happen? Because we are replacing a minus, but there is already a minus on this fraction. So this part is going to be a positive. Take note on this part. So it is going to be positive 2 over, now we are having x minus 1, which is written in terms of x, positive x. So the negative that we factored out, this one, is the one that affected this negative here and gave us a positive. That is the idea there. Okay, so as we know that at this stage we need to find the LCD, where we need to take from the factors the brackets. So you have x minus 1 and we have x minus 2 and x minus 1 in this case. Take note, x minus 1 and x minus 1 are the same, so you don't need to repeat. So now let's divide our LCD, divide by the LCM, the common denominator here, the denominator in this part here. So as you can see, these two are the same. So if we divide this LCD divide by our denominator here, we are going to obtain a 1. That 1, we multiply the numerator, so it's 1 into x plus 1. Plus, we do the same in this case, our LCD divide by x minus 1. So as you can see, x minus 1 and x minus 1 will cancel. You remain with x minus 2. So it will be 2 into x minus 2 like this. Okay, let's expand our brackets and simplify further. That's 1 into x, which is x, 1 into 1, which is 1, 2 plus 2 into x, which is 2x, plus 2 into minus 2, which is minus 4, everything over x minus 2, x minus 1. Okay, now let's collect like terms. We have x and 2x, which is 1x plus 2x, that's 3x, 1 minus 4, 1 minus 4 from our calculator, we are going to obtain minus 3 from this part. Okay, everything over x minus 2, x minus 1, like this. So at this stage, we have to cross-check if there is a part that we can actually factorize if like the numerator in this case, 3 is common. So we can actually factor out 3, which is common, which is going to give us 3 into, if we factor out 3 here, from 3x is going to be positive x. 3 here is going to be minus 1 into x. We have divided by x minus 2 divided by x into x minus 1, like this. And x minus 1 and x minus 1 are the same. And these are multiplying, these two are multiplying, these two are also multiplying these two brackets. So you can actually cancel x minus 1 and x minus 1. So that means we are going to remain with 3. On top, we are going to remain with 3 over, on this part, we are going to remain with x minus 2. So that is what we are having from this expression. So as we can see, it's a matter of simplifying the expressions that you have, factorize and expand by dividing and working with brackets. So you have to expand the given brackets. That's the whole idea there. Okay, then on question number 2, you are given to solve for x in each of the following equations. Okay, so these are the equations that you are given, and we had something about 13 marks for that, to solve these equations. Okay, so we shall focus on them and see what we have in this part. Okay, so the first equation on question 2 is we are given to us 25 to the exponent of minus 2x plus 1. Take note, this is minus 2x plus 1, which is multiplying 5 to the exponent of, this is x over 2, everything over 125 by x to the exponent of minus 1, equivalent to 1. Okay. If we are to cross-check in this part, yes, we are working with the equations that we have in this case, where we have fractions. We can get rid of these fractions by cross-multiplying both. This one is same as over 1. So if we are to cross-multiply, this is going to remain as 25 to the exponent of minus 2x plus 1 by 5 to the exponent of x over 2, which is equivalent to 125 multiplying 1 is going to be 125 to the exponent of x to 125 to the exponent of x minus 1, 125, which is raised to the exponent of what? Of x minus 1. Okay. Now from this part, we are multiplying on the left hand side, and we can't simplify this because the bases are not the same. So we have to make sure that the bases are the same, so we can actually simplify everything throughout the equation in terms of the same base, of which the base that we can talk about is 5. So 25 in base of 5 is same as 5 to the exponent of 2, but is going to affect the whole expression of minus 2x plus 1. Okay, multiplying by 5 to the exponent of x over 2, which is equivalent to 125 in the base of 5 is 5 to the exponent of 3, also affecting the whole thing, which is x minus 1. Okay. If we are to take note in this case, we are having a condition where we are multiplying and the bases are the same. And we know that from our laws, we have to add the exponents. So if we are to add the exponents, we are going to have 5 to the exponent of here. So this one, let's just simplify, is 2 into minus 2x, which is minus 4x, 2 into 1, which is positive 2. Okay, plus, because we are multiplying by this 5 to the exponent of x over 2, so it's going to be plus x over 2, which is equivalent to 5 to the exponent of 3 into x, which is 3x, 3 into minus 1, which is minus 3. Okay. Here we are now having a condition where we have two bases, one on the left and the other one on the right. So we know that when we have this condition from x to the exponent of a, which is equivalent to x to the exponent of b, as long these bases are the same, it also means that the exponents are the same. A will be equal to b. So from this part we can take note that the exponents, which is in this case this part of minus 4x plus 2 plus x over 2, is equivalent to this part of 3x minus 3. Okay, so that is part that we are going to equate, but on the left hand side we can simplify this because we have minus 4x plus x over 2. X over 2 is same as 1 over 2x. So we are simplifying minus 4 plus 1 over 2. So it's minus 4 plus 1 over 2, which is giving us something like minus 7 over 2 or minus 3,5. Okay, so we have 5 to the exponent of minus 7 over 2, which is same as minus 3,5x. Okay, so plus 2, which is giving us 5 to the exponent of 3x minus 3. So now we have this part which we can see clearly, which is minus 3x minus 3,5x plus 2, which is equivalent to 3x minus 3, like this, taking from the idea of the bases which are the same. So now we can solve an equation whatever way. So this one we can take 3 to the left hand side so that it becomes positive 2 plus 3, which is equivalent to 3x minus 3,5 to the right hand side is going to be plus 3,5x. So we add and simplify. This one is going to give us something like 6,5 from your calculator, 6,5x. So therefore x is going to be 5 divided by 6,5, which is something like 5 divided by 6,5, which is 10 over 13. That will be the value for x. So that is what we are having from this part here. So it was just a matter of simplifying using the laws of exponents, and also knowing the idea of working with the same base, and knowing that when you are working with an exponential equation, when the two are in the same base like this, also the exponents are equal. If these two are the same, these bases are the same, it means also the exponents are the same or are equal. Okay, so that's what we had from this part, and the other part was log 9 log x base 3, 9 log 3 base x, which is equivalent to log x in base of 3, and you asked to solve this one. It carried about 6 marks to just solve that equation with about 6 marks, where we are given to solve 9 log 3 base x, which is equivalent to log x base 3. Okay, as we can see here, we have equations, an equation actually in log format, but the bases are not the same. If we are to cross-check properly, this base is x and this base is 3. So it's very, very difficult for us to solve such an equation unless we are to write this in the same base. So in the same base, we understand this from the law of log, that if we have, let's say, log a in base of b, we can rewrite this as 1 over log b base a. The moment we introduce that 1 over, these two are going to interchange. So it will be log b base a. So applying this law, if we are to apply this law, it's going to be 9 by, in place of log 3 base x, if we are to apply this law, is same as 1 over log. The moment we introduce 1 over, it means these two are to interchange. So it's going to be x in base of 3, like this. So This is 9 by, which is equivalent to this part. We are not going to interchange anything because we are now having log x base 3, which is the same as this part, log x base 3. Okay, this is 1 over, and it's multiplying 9. So if you are to write properly, it's supposed to be something like 9 over like this. This is what you're supposed to have, because this one is same as 9 over 1. So it's 9 times 1, which is 9. 1 by log x base 3, which is going to be log x base 3, which is equivalent to log x in base of 3, which is same as over 1 since we have a fraction. So in order for us to solve for x, we have to cross multiply, where if we are to cross multiply, in this case it's 1 by 9, which is giving us 9. So I can just write it somewhere here, which is giving us 9, equivalent to, so we have multiplied 1 and 9, which gave us 9, log x base 3 and log x base 3. So these two are the same, just like 2 times 2, that is same as 2 squared. So if we are multiplying these two, which are the same, is same as writing it as log x base 3 squared. One and the same thing. One and the same thing. But we have to solve for x in this case, and there is a square. So how can we remove this square which is affecting our log? We can introduce the square root. Remember, if we have a square, to get rid of this 2, introduce square root. The moment you introduce square root, the 2 is no longer there. So square root of 9 is plus or minus 3, which is giving us log x in base 3. We have taken the square out by introducing the square root. So as you can see, we have two answers from plus or minus. So definitely our logs are going to be something like this. Log x base 3 equal to 3, or another one, log x in base 3 equal to minus 3, because we have two answers in this case. So how are we going to find x? Okay, let's refer this back to this law. We know that from log a base b equal to x, I told you that a is equivalent to b to the exponent of x. So if we are to apply this concept, you see that a, in this case we have x, so it's going to be x equivalent to 3 to the exponent of 3, or another x, which is going to be this x equivalent to 3 to the exponent of negative 3. So from your calculator, x is going to give you 27, 3 to the exponent of 3, or the other x is going to give you negative 1 over 27 from your calculator. So these are the values of x that we are referring to, or that we are talking about. But if we are to cross-check from the normal part that we had, our x can never be a negative. We cannot have a condition where we have a base being a negative, or even a number being negative. So now what are we going to actually write? We are going to have our x being equivalent to 27, because we cannot have a condition. What I'm saying is that if you are to replace minus 27, guys, let's take note, we have something like log, and we have minus 1 over 27 like this in base 3 from log x base 3. If we substitute x, but this does not make sense, doesn't make sense because of the negative here. Log cannot have a negative. This one is, you're not going to obtain an answer from this part, which means it's invalid or does not exist at all. So that is why I'm saying you have to work with the positive values. Okay, so that's what we had, and we are asked to solve or to simplify the following. Okay, I'm going to write that expression that we are being asked to simplify. X minus 2x to the exponent of a half plus 1 like this, over x to the exponent of half minus 1. How actually can we simplify this type of an expression? what we are supposed to ask ourselves in this case is that if we have a condition that we have x to the exponent of half, and also here we have x to the exponent of a half, how can we rewrite this same x in terms of x to the exponent of a half? Okay, let's write it in this way. If we are to write it in terms of x to the exponent of a half, which exponent are we going to raise this exponent with this half, x to the exponent of half, so that we obtain the same answer as what we had both? This one was x, which was same as x to the exponent of 1. So which number are we going to use so that if we say half multiplied by that number is going to give us 1? So it's supposed to be 2. Half of 2, it's 1. So you simply find the inverse of this number. The inverse of half, it's 2. So half times 2, it's 1. So as you can see, we haven't interchanged or changed anything. We just rewrote this expression into another format, but giving us the same thing. Okay, minus, since this one is in the already in the x to the exponent of half, we just leave it like that, plus 1 over x to the exponent of half minus 1. There is a certain type of an expression that we are obtaining which is difficult to work with if we are to work with those exponents of half. So we can make it easier by introducing a certain letter in place of x to the exponent of a half, like this, where we can actually say let y be equivalent to x to the exponent of a half. You just choose any letter of your choice. So if we let y be equivalent to x to the exponent of a half, it means in place of x to the exponent of a half like this, we are replacing with y, which is going to give us something like y squared minus, in place of x to the exponent of half, we have y, which is 2y plus 1. Everything over, in place of x to the exponent of a half, we have y. So this one is going to give us y minus 1. So we have interchanged this to write it in terms of y. So as we can see from this part, we have to factorize. We have y squared minus 2y plus 1. So we have to at least factorize this. That is, we have y and y, since the coefficient of y squared is 1. So focusing on this one, what are the factors that you are going to have of 1 that we add to obtain minus 2? So this one is minus 1 and minus 1. So we are going to have y minus 1, y minus 1. So that means in this case we have something like y minus 1, y minus 1, everything over y minus 1, like this. If we cancel out these two, we are going to remain with y minus 1. But we cannot have our final answer after cancelling as y minus 1 like this, because this was an expression for x that we are talking about. So we have to now refer back to the introduction of y, where actually y came from. Y came as an introduction where we said let y be equivalent to x to the exponent of what? X to the exponent of half. So in place of y, we can now substitute that part that was actually there into the normal expression, which is x to the exponent of a half minus 1. So that will be our final answer, since the other bracket are cancelled with another bracket. So that is going to be the resultant or the final answer from this part that we are given. Okay, then we are also given in this case on question 3 that the perimeter of a right angled triangle is 40 meters if the side adjacent to the right angle is 8 meters, calculate the hypotenuse and the area of the triangle. So we have 6 marks for that. This was a question which was actually referring us or wanted us to apply something about solving triangles, where we have to apply a right angle triangle, because we are given that the perimeter of a right angle triangle is 40 meters. So from the properties of a right angle triangle, we all understand that from our Pythagoras theorem, we have the hypotenuse squared, which is equivalent to a squared plus b squared, which is the shorter sides, or we can write it this one as c squared. So the shorter sides, we are just referring to a, b, and this is our h, something like this. This is the triangle that we are talking about. And we are given that the perimeter, that is after adding everything, we are supposed to obtain 40. And if a side adjacent to the right angle, so in this case, we have this side and this side. So either of this side, we have 8 meters. Okay, so let's say we have our A as 8 meters. And the perimeter is 40. And we know that perimeter is as a result of adding everything. The distance, perimeter is the distance right around the shape. So that means if we add A plus b plus h, we are supposed to obtain the perimeter of 40. That is a, b, and h, everything. But we know that we are given that a is the other side. Here is just an assumption. So you can choose this side to be b. We can choose it to any part. Here I've chosen it to represent a. What we need is to find the value of a, the value of b, the value of h. After finding these values, everything is going to be clear. So your a, you just choose, that 8, you just choose which side you want to use it as your 8, either a or b. Okay, so in this case, I've chosen it to represent a. So that means in place of a, we can replace with a with 8. So I can actually formulate an equation such as b plus h, which is equivalent to, if we are to take h8 to the other hand, is going to be 40 minus 8 from your calculator. You obtain something like 32. Okay, let's just leave it like that as an equation. What other parts that you can use? Because still we have b and h, so you can't solve for b and h because we have 2 unknown values there. So we have to formulate another equation. So where can we formulate the equation? Back to Pythagoras theorem. We know that from Pythagoras theorem, h squared is equal to a squared plus b squared. We have h squared, which is equivalent to, let's substitute a. In this case, because we choose a to be 8, so it's going to be 8 squared plus b squared, like this, which is h squared plus, which is h squared is equal to 8 squared from your calculator is going to be 64 plus b squared, something like that. So as we can see, also we are having another equation in terms of h and b, but let's try to have something in this format. Here we have b plus h. So how can we have it in terms of b and h? So you can actually take 64 to this end, it's minus 64, which is equivalent to h squared. To this end is going to be b squared minus h squared. So which means this one can also be rewritten as b squared, something like this, b squared minus h squared, equivalent to minus 64. So we have actually formulated another equation. So how can we solve for b and h now from these two equations? Yes, there are so many methods, guys, that we can use to solve these equations, where we can make b the subject, then we substitute here. But what are we actually seeing here? B squared minus h squared, this is a difference of 2 squares. Okay, this is our second equation, our first equation. So from the second equation, This one is a difference of two squares, which is being taken from b plus h, b minus h. This is from the difference of two squares, this one, b squared minus h squared, but is equivalent to minus 64, which is equivalent to negative 64, like this. But we are given an expression for b plus h, because wherever we see b plus h is the same as we are seeing this number, which is 32. So in place of b plus h, we can substitute 32. Like this part here, we have b plus h. So in place of this b plus h, we can substitute 32 like this. So that means we can find an expression or the answer for b minus h, since we are now having something like 32 into b minus h equal to minus 64, like this, so that we can divide by 32 by 32. So our b minus h can give us something like 32 into minus 64, which is minus 2. So we are now having a linear equation. Instead of working with this quadratic part, we can now work with this linear equation where we have b minus h equal to minus 2. So as you can see, this is our equation 3. So it's easier for us to solve equation 1 and equation 3. Why? Because both are linear. This one is a linear, the highest exponent is 1. This one is also a linear, the exponent is 1. So you can write them down, these two equations. The first equation, so we are now solving first equation and last equation. So the first equation is b plus h, which is equal to 32. And the third equation, which was b minus h equal to minus 2. So as you can see, it's now easier to solve this equation. How can we solve it? This is our equation 1 and this is our equation 3. So we can actually subtract equation 3 from equation 1. So let's subtract so that we can eliminate b. So it's b minus b, that says 0. H minus h, this one is same as 1, 1. So it's 1 minus minus 1, which is 2h, equivalent to 32 minus minus 2. From your calculator, you're going to obtain 34 from your calculator. If we divide by 2, h is going to give you 17 from your calculator. We need to find the value of b, so we can actually substitute into any of these equations. So since we have h, we can have b plus h, which is h is 17, equal to 32, like this. So let's find b. b is going to be 17 to the other hand, which is going to be a negative. So it's 32 minus 17. Let's see from our calculator, 32 minus 17, which is 15. So b is going to give us 15. Okay, so in order for us to answer the question, we have to go back to the diagram that we had. Let's replace these values. Already we said a is 8, b is 15, and h is 17, something like this. Yeah, it must make sense if we have something like this. So let's have the question again and see what we are asked to find here. The question is asking us to calculate the hypotenuse and the area of the triangle. The hypotenuse and the area. So the hypotenuse, we found it. The hypotenuse in this case, it's 17. So answering the question, we are now writing our hypotenuse, which is 17, and these units are in meters. Okay, this is the first part. The second part is the perimeter, and we said perimeter is sorry, it's not perimeter, but the area of the triangle, which is a right angle triangle, of which you know that the area of a right angle triangle is half BH, half base by the perpendicular height, which is in this case is half by, this is the base and that's our perpendicular height. So we have a base of 8, perpendicular height of 15, so it's going to be half of 8 by 15. So that's what we had. As you can see, if we have the values, it's going to be pretty easier to calculate all these values that you are being given. So it's just a half multiply by 8 multiply by 15. So that's 60 for us. So we're going to obtain 60 and meters, which is going to be square meters. So as you can see, whenever you are working with these questions, try by all means, guys, that you focus on the units also. Formulas versus units. So it's formula versus units. That is what you need to take into consideration. Okay. We are given 3.2 to make x the subject of the formula. Make x the subject of the formula there. Okay. Let me just write down the question. We have P1 plus P2 equivalent to r to the exponent of x, and we want to make x the subject. Okay, we already have a single term here on the right hand side, so you can actually introduce log so that you can simplify. So you can choose to introduce ln if you want. For, let's say, introduce log. This is going to be affected under single log, so it's going to be log P1 plus P2 equivalent to log r to the exponent of x. I have introduced log. The moment I introduce log, which means here I can now drop this exponent so that it becomes log P1 plus P2 equivalent to x log r, like this. Okay, we need to find the value for x in this case, so we can divide by log r so that x is going to be log P1 plus P2, everything over, because we have divided by log r, so it's going to be over log r, like this. So we have made x the subject. That is what we have. But how can we rewrite this in another way or another format? Let's refer back to logarithms. Log a, or let's just say log m over log n, whatever that you're given, in actual sense is the same as log m in base of n. So if we are dividing logarithms, it's same as writing it as log m in base of n. So that means from these two logarithms which are dividing, we can actually write this as log P1 plus P2. We are dividing by log r. The one that is dividing is going to be the base. So we are dividing by log r. So r is going to be the base, like this. So we can have our final answer as this, where we have x being equal to log P1 plus P2, or in base of what? In base of r. So this can be your answer, or you can even leave it at that stage. It's still fine. It's still fine like that. Okay, so that's it for this question, and we are given to solve the equation. Solve the equation if x is not equal to 2. Okay, that's the equation of x squared plus 4. Let us just write it down. Over x minus 2 minus 3x minus 8, everything over 3. And it's equivalent to 0, like this. And you're asked to solve for x. Solve the equation. Okay. If you are to cross-check on a view that you are having, it seems as if we are supposed to be subtracting these fractions. Yes, it's true, you can subtract them, but to make these fractions easier, you could just cross multiply. But in order for you to cross multiply, you must have a condition where you have two fractions, one on the left, the other one on the right. So to achieve that, you are going to have something like x squared plus 4x over x minus 2. Then take this fraction to the other side of the equation, since there is a 0. So you can just write it on the other side. So minus to the other side of the equation is a plus now. So it's going to be plus 3x minus 8 over 3 like this. So you have at least reduced the burden of addition and subtraction there. We just need to cross multiply from this stage. So let's cross multiply and see what we have. 3 is going to multiply, this is x squared. So it's 3 multiplying everything. So it's 3 into x squared plus 4, which is equivalent to this side multiplying that side, which is 3x minus 8 into x minus 2. That is what we're obtaining after the cross multiplication. Okay, now let's simplify further and see what we have. We have 3 by x squared, which is 3x squared, 3 by 4, which is 12 from our calculator, which is going to give us 3x. Here we are going to expand brackets, so it's 3x by x, which is 3x squared. We move on, 3x by minus 2, which is minus 6x. Okay, minus 8 by x, which is minus 8x, minus 8 by minus 2, that's minus and minus, which is going to give you a positive 16. Okay, collect like terms, so you can just collect like terms on one side of the equation, so that it's better that way. So you have 3x squared plus 12, which is equivalent to, here we have also 3x squared minus 8 and minus 6 and minus 8 from your calculator. If you subtract minus 6 minus 8, you're going to obtain something like minus 14x plus 16. Okay, now at this stage we can write this by collecting. As you can see, if we take 3x squared to 3x squared, it's going to be 3x squared minus 3x squared, which is a 0. So this cancels. So we are no longer having a quadratic because these two are going to cancel. So we can now take minus 14x to the left hand side so that it becomes a positive. So we'll be having something like 14x equal to positive 12 to the right hand side, which is going to be a negative. So it's going to be 16 minus 12, which is definitely 4, because we are subtracting a smaller number from a bigger number. So it's going to be positive 4. Divide by x by 14 by 14 so that we obtain x. So it's going to be something like 2 over 7 from your calculator. So that is the equation which is carrying 4 marks. So as you can see, guys, if you are working with questions, when you are working with questions from these equations, figure out the type of equation that you are given and how can you simplify, or how can you work it out throughout the given process that you are using. And also never make mistakes when you are working equations, because once each part is affected, everything is affected, and that means the value of x is going to be wrong. So make sure that you apply this good concept. As you saw that on question 3, it's all about equations. Yes, we're working all about equations, all about it. Even this change of subject, the procedure or the process or the steps that you follow, these are the steps that you use even if you are solving for x. Yes, you are finding x as a subject, but it's this also the steps that you follow when you had actual values. Okay, so that's it, guys, from this question paper which was written in February 2022. So we shall have the part 2 in the coming days. So not to miss these classes, please make sure that you subscribe to my channel, Mason African Motives, as we'll be working on questions from past exam papers and so forth under this platform. And also let's not forget to share our videos to our colleagues and friends so that they also can benefit from the same information that we have. So that's it, guys, till we meet again.